Hello everyone. In the following section, we'll describe a strategy for checking ramp wall stability, like I mentioned above. And like most structural components, we'll have to check external and internal forces, or first the global overturning of the ramp, experiencing lateral hydrostatic forces from fill and material, and second, internal stresses on stone masonry ramp walls, shear and flexure, while resisting lateral hydrostatic forces from the fill material. Now, ironically, the grout fill, or slurry mix, was implemented to reduce the development of lateral pressures from the rock fill. Abutments used to be filled with only loose rock material. However, during the construction process, the grout fill increases the lateral pressure on the ramp walls. After curing, grout eliminates lateral forces from the rock onto the ramp walls that will develop over time. Now you can think about this as these lateral forces as if you build up a big pile of rock, over time, we're expecting that rock pile is going to settle. It's going to settle from where you built it up to its internal angle of friction or its angle of repose. And when it is constrained by structure, as it settles, it's going to be creating outward forces on those walls and on that structure. Now, it's also worth noting that the split tensile strength of cement mortar with no additives can be taken as a conservative 0.1 megapascals. So I have that here. After 1 day of curing, based on figure 6 in the study I'll link below. It's almost like the resistance, and we can think of this almost like the resistance to getting squished of the ramp fill, or the cement mortar, sorry. And we'll consider this to be the only thing adding capacity to the ramp fill. Now, compared against the forces from the rock captured within the slurry block and against the surcharge loading of rock and slurry mix above. So I drew, an example of what a standard split tensile stress test setup might look like here. So we can consider that force above to be combining with the force of the rock wanting to actually split the block from the inside out. And a quick number comparison shows that this shouldn't be a problem. This check is not performed here. It's not performed in the manual or in the course, but it is just reported, and I wanted to explain that it is here for your information. And then in the next lecture, we'll get right into the first check, our global overturning.